Okay, we are still solving equations. We've got a couple more learning targets to go, and the first one we're going to talk about is variables on both sides. And we've looked at one of these already in an exit slip just to kind of get an idea. And a lot of the concepts that we've used in multi-step equations we'll use with these types of equations. So we're going to jump into our first example, and I've already got this one written. In this example, 5x plus 13 equals 2x plus 22. Now I have that line down the middle. Some of you all have been using that. The reason I have it drawn on this one is because I want you to think of it as a wall. I want you to think of the equal sign as a blocker or a wall. You all know how to collect like terms. So immediately a lot of you all are probably visualizing that the 5x and the 2x can be collected together because they're like terms. But what I want you to keep in mind when you approach these problems is that you have this wall here because 2x is on the right, 5x is on the left. I can't put those together, only because they are separated by the equal sign. They have to be on the same side in order to collect like terms. So that's something to remember. They must be on the same side. The same thing goes for the 13 and the 22. Those are like terms, but they're not on the same side, so I can't just add those together. What I have to do is move one of these variables to the other one. So we either have to take the 5x and move it over here, or I have to take the 2x and move it over here. Now, my suggestion, now this is just a suggestion because this is not how you have to do it, but my suggestion to try to eliminate having to use a lot of negative numbers is to identify the lowest coefficient or the smallest coefficient of x and move it to the largest one. Now, coefficient is a vocabulary term you should already know. 2 is a coefficient of x in this expression right here. It is the number in front of x. The coefficient in this expression is 5. It's the number in front of the variable. So I'm going to go with that suggestion just to show you, but when you're looking for these, 2 is smaller than 5. You all know that. So what I'm going to do is I'm going to move this 2x over here to the 5x. Now, a lot of you all want to think division, which is not completely incorrect. You could technically divide all of this, but you're going to get into a lot of, you're going to get into some fractions there. So we're going to eliminate that. I want you to move all of this at once, the 2 and the x together. This is like one term that we're moving all at once. And so if I ask you, what is this? What type of 2x? Hopefully you would respond with a positive. There's an understood plus sign here, because remember it's a positive 2x. So the inverse operation would be a negative 2x, or to subtract 2x. That's a positive 2x, I'm going to subtract 2x. Now when you bring that over here to the left-hand side of your equal sign, you have to make sure you line up your like terms. So you want to put that right under the 5x, not the 13. Those are not like terms. And notice that I'm only doing that once. I subtract 2x from this side one time. I subtract 2x from this side one time. Okay? So what that's going to do, we're going to go left to right here. 5x minus 2x, that will leave us with 3x. Don't forget about your plus 13. We haven't done anything with that yet. Now we've hit our equal sign. And 2x minus 2x, that's where we get our 0. That's how we are able to eliminate the 2x from that side. And all I'm left with is a positive 22, plus 22. Again, that means positive. We've already talked about that. So there's no reason to write the plus sign there. We understand that to be a positive 22. And at this point, you're at a two-step equation. You're back to the second learning target of solving two-step equations. Solving two-step equations, the inverse operation of adding 13 is to subtract 13. So again, make sure you go from one side of the equal sign to the other. So on this side, positive 13, negative 13 is where I get my 0. So I'm left with 3x there. And then on the other side, I've got to do 22 minus 13, which is going to leave us with 9. And then I'm going to leave that for you all to finish because you should be able to solve the rest of that for x. But new content here is moving your variable from one side to the other. Sometimes you go left to right, sometimes you go right to left. It's going to vary. But moving your variables to the same side. Now I want to look at one more example with solving equations when you have variables on both sides. And really the reason I want to look at this example is because it's going to get us into some of the multi-step equations that we looked at previously. So here's example 2. 2 times the quantity 3x plus 1, so when I say quantity that means it's in parentheses there, equals 4 times the quantity x minus 5. Now you've had some like this already as far as having the number there in front of the parenthesis. And a lot of times I will ask, well, what do you do when you have a number directly in front of the parenthesis, not added to the parenthesis? There's no addition sign here. When this is side by side, it's understood to be multiplication. So that brings in your distributive property, which most of you all can do that. So make sure, just as a warning, that you distribute to everything that's in this parenthesis. So sometimes the arrows help to keep you lined up. We will do a lot with distributive property, and it will get a lot more difficult when we get into our exponents. So make sure that you are right now remembering to distribute all the way through the parenthesis. So that's going to give you 6x plus 2. I multiplied everything by 2. And on the other side of our parenthesis, when we distribute that 4 to the x and the 4 to the negative 5, that's just a 1x. That's a 1 there. You could put that there if you'd like to see it. 4 times 1x is 4x. Remember, you're multiplying, not adding. And then 4 times negative 5 is negative 20. Whatever you say, that's the sign you use. If you say a positive number, you put a plus sign. If you say a negative number, you put a negative sign or a subtraction sign. Same thing. So now example 2 looks like example 1. We've got our wall there, our equal sign, and on one side we have 6x and on the other side we have 4x. The smallest variable, the smallest coefficient is 4, so I'm going to move this 4x to the 6x. The exact same problem as above. What is the inverse of this positive 4x? The inverse is a negative 4x. So subtract 4x from the right of the equal sign, and come over here and subtract 4x from the left. So let's just work this left to right. 6x minus 4x gives us 2x. Don't forget about your plus 2 that's still there. We've hit our equal sign. Some of you are leaving your equal sign out when you're working. Always work left to right and write the equal sign in. Here's our 0 that we were looking for, and in this problem we're left with minus 20, or in this case, now that it's no longer a subtraction problem, it's just negative 20. We have to keep that sign. The inverse of adding 2, because we're at a two-step equation now, is to subtract 2. So 2 minus 2, this gives us our 0. So the only thing we're left with on this side is 2x. And then once you do negative 20 minus 2, I'm going to write this problem over here. You're left with 2x on the left, negative 20. If you're down 20 and you go down 2 more, you are down 22. And you have a one-step equation, so you should be able to finish that out to solve that one for x. So those are variables on both sides. Now, I do want you all to understand that not all equations are going to have one answer. And we'll discuss that more in class. We may have no solution. We may have infinitely many solutions. So that's something we'll discuss in class. The next concept I want to look at, and this is our last learning target, are literal equations and formulas. Now, literal equations are equations that involve 2 or more variables. So there's you a definition, 2 or more variables. And you all have seen literal equations before. If you remember graphing in previous years, you've graphed problems that have looked like this potentially, 2x plus, or y equals 2x plus 1. That is a literal equation. There are 2 variables in that equation. Now, usually you call that slope-intercept form, if you all remember that. You may have talked about functions, but those are literal equations. So what we're going to look at is we're going to look at this literal equation. Here's your example 1, 3x plus y equals 10, and we're going to solve this for y. So they have specified which variable they want us to solve for. Now here's an important question to think. Why should you rewrite the equations? Any of these literal equations, why should you rewrite them? Well, the reason you should rewrite them is because to solve an equation, even when we were solving equations like these, we were isolating the variable. So we were getting the x by itself. They want us, in this problem, to isolate y. They want y by itself. Well, if I were to give you values of x and ask you for y, I could give you a table. I don't want you to write this, but I just want you to think, because you all have seen this before. If I gave you a table of values and I told you that x was equal to these 5 values, and I want to know what's y. Well, what you're going to have to do is you're going to have to plug -2 in for x, solve for y. Then plug -1 in for x, solve for y. Plug 0 in for x, solve for y, and so forth. So basically what you're going to have to do is you're going to have to solve for y 5 times. But if you go ahead and isolate y first, if you solve for y first, then all you're going to have to do is plug in each one of these values for x and just simplify, order of operations. So, but you're making things easier on yourself is a big thing there with rewriting these equations. So what I'm going to do, I'm just rewriting this down here, 3x plus y equals 10. Let's think about this. I want y all by itself. I'm going to put an arrow here. I do not want to move that. I do not want y to move. What's on the side with y that has to go? Obviously not the 10, it's over here. What's over here that has to go? On the same side as y is this 3x. I've got to get rid of this so that I can isolate y. How do I move a positive 3x over to the other side of the equal sign? Over there with the 10. How do I do that? You just learned that with solving variables on both sides. This is a positive 3x, so the opposite or inverse of a positive is a negative. Now notice when I write it over here on the right-hand side of the equal sign, I did not put it under the 10. I intentionally did that because I want you to keep in mind that 10 and -3x are not like terms. This one has a variable, this one doesn't. So let's simplify this left to right. 3x minus 3x. Positive 3x, negative 3x. This gives us the 0 that we wanted. So all I'm left here is the positive y, which is that's what I was doing. That was my goal, to isolate y. On the other side, I have a subtraction problem because I can't technically put those together. So I just simply have 10 minus 3x. I literally write it, this is my literal equation, I literally write it exactly how I see. I can't combine those because they're not like terms, so I just write it as a subtraction problem. And that's it. This is my answer right here to that literal equation. I isolated that for y. So now if I wanted you to do this, I could have you plug -2 in for x and simplify. Plug -1 in for x and simplify. So rather than solving for y 5 times, I solved it once. And now I can just use order of operations or even my calculator and get my answers much more quickly. All right, so those are your literal equations. The last thing that we're going to look at here real quick are formulas. So here's another definition, your last definition. A formula is an equation that states a relationship among quantities. Now, I don't want you to write these. I just want you to look at this. These are some common formulas that you all have seen before. Now, I know not all that is in the picture, but perimeter of a rectangle, circumference of a circle. I know a lot of you all should know area of a triangle. So these are some common formulas that you may have seen before. Temperature, you may see some in science. So when we are talking about formulas, we may be given a formula like this example. The circumference of a circle is 2 pi r, and they want you to solve for r. Okay, well look at what you have here. I do not want to move this r. I do not want that to move. What's stuck to it? There's a 2 and a pi. Both of those are stuck to r. Then ask yourself, how are they stuck to r? Well, they're stuck by multiplication. Because they're all side by side, so that's multiplication. The inverse of multiplying by 2 pi would be dividing by 2 pi. But I can't divide c by 2 pi, not really. But that would be your answer. And we'll go over that more in class.